Okay, so get this. You want to understand quantum computing, and wow, you've really gone all in here with all these articles and notes you've got. And we're going to do a deep dive into this world that honestly sounds like something straight out of Star Trek, but it's becoming very real and very fast.
It's definitely a fascinating topic, and yeah, these sources are a great starting point.
So let's start with the basics. What is quantum computing? I keep hearing about these things called qubits and how they're different than the bits in our computers.
Yeah, it's a pretty big shift. So you know how the bits in your phone or laptop, they're either a 0 or a 1? Well, in quantum computing, you have these qubits, and here's where things get kind of crazy thanks to something called superposition. A qubit can be both 0 and 1 at the same
Whoa,
time.
whoa, whoa. Back up a second, both at the same time. Now that's just messing with me.
Yeah, it's not exactly intuitive. It kind of goes against how we normally think about things. Maybe this will help. Imagine flipping a coin while it's spinning in the air. Is it heads or tails?
Well, I mean, until it lands, it's kind of neither or both, right?
Exactly. It's in this fuzzy state of being both possibilities at once. And that's kind of what superposition is like for a qubit. It's not fixed. It's not determined until it's measured. So now imagine a computer that can explore tons of different possibilities all at the same time, just like that spinning coin. That's the kind of power we're talking about with qubits and superposition.
Okay, I think I'm starting to get why this is such a big deal. So instead of like checking one path at a time, a quantum computer could explore like a whole maze using every path simultaneously. That would be insanely fast.
And that's just one part of it. There's another quantum superpower we need to talk about, and this one is really mind-bending: entanglement. Basically, you have two of these entangled qubits that are linked together even if they're miles apart. You change one and the other one changes instantly.
Hold on, wait a minute. Isn't that like spooky action at a distance? It's like they have this secret connection or something?
That's exactly what Einstein called it. Spooky action at a distance. And that connection is what makes quantum computing so powerful. You can basically share information across these entangled qubits instantaneously. It's like they're working together on a whole different level.
So we've got superposition entanglement. Is there anything else these quantum particles have up their sleeves?
Oh, yeah. There's also quantum interference. It's kind of like waves. You know how waves in the ocean can either like build each other up or cancel each other out? Well, in quantum computing, this interference can help guide the computation towards the best solution, like a wave pushing us in the right direction.
Okay, so we've got these incredible quantum properties. But how does this actually affect us? I mean, in the real world, how does this actually make a difference?
Well, for example, quantum computing is being looked at as a game changer in fields like drug discovery. You know, your sources mention this, the possibility of designing drugs at the molecular level using quantum computers.
Yeah, I'm really interested in hearing more about that. How would that even work?
Well, imagine being able to design a drug that fits perfectly with a specific protein in the body, almost like a key in a lock. This kind of precision could lead to incredibly effective drugs with way fewer side effects.
Wow, that's pretty amazing. It'd be like having a molecular blueprint for creating these super targeted treatments.
And that's just one example. It could also completely change how we model financial markets. Instead of just, crunching historical data, these computers could make predictions with a level of accuracy we've never seen before.
So basically, Wall Street is going to need to hire a bunch of quantum experts.
Yeah.
What about like climate change? Could it help with that?
Definitely quantum computers could help us create these super complex climate models. Think about it being able to predict weather patterns with pinpoint accuracy, or really understanding how all these different factors contribute to climate change.
So we could be looking at better forecasting, more targeted interventions. It seems like these computers could actually help us tackle some of the biggest problems we're facing. What about the downsides? Are there any potential downsides to all this quantum power?
Of course, there are challenges. One of the biggest ones mentioned in your sources is error rates. These quantum systems are incredibly delicate, and even the tiniest disturbances can throw them off.
So it's kind of like building a house of cards during a hurricane.
Yeah, a very, very sensitive house of cards. Building and maintaining these qubits so that they hold their quantum states, it's an incredibly difficult engineering feat. On top of that, there's also the issue of scalability. Right now, we're working with just a handful of qubits. To really unlock the potential of quantum computing, we need to figure out how to build systems with thousands or even millions of these qubits all working together perfectly.
So you've got this incredibly delicate dance of creating these qubits and then the monumental task of scaling them up. It makes you wonder who's actually leading the charge in this quantum race.
It's actually a pretty diverse group.
Yeah.
Some of the big tech companies like Google, IBM, Microsoft, they're all heavily involved. But then you've also got these more specialized companies like D-Wave and Rigetti, each with their own unique approach.
So it's like a global brain trust forming around this technology. It's fascinating that they're all tackling different aspects from the hardware to the software and even specific applications.
Exactly. It's like a multi-pronged attack on the challenges of quantum computing, with each company bringing its own expertise to the table.
Speaking of breakthroughs, do you remember when Google claimed they achieved quantum supremacy?
Yeah, that was a pretty big deal, right?
It was a huge milestone. Basically, what they did was use their quantum computer to solve a problem that would have taken a classical supercomputer an insanely long time. Like, we're talking thousands of years.
So they basically proved that these quantum computers are in a whole different league. It's like comparing a horse and buggy to a supersonic jet.
Exactly. It was more about proving the concept than solving a practical problem. But it was a major statement to the world that these quantum computers can outperform classical computers in ways we never thought possible.
It's like the first time a plane successfully flew. Maybe it didn't take us to the moon right away, but it proved that flying was possible. And
Yeah.
now look where we are. And since then, the field has just exploded. Researchers are constantly pushing the limits, building more stable qubits, increasing their numbers, and finding new ways to harness their power. You know, this deep dive is only the beginning. There's so much more to uncover, especially when we start looking at how all of this is going to affect us in the coming years.
Well, we've covered a lot of ground, but it feels like we're just getting started.
Yeah.
There's still so many questions to answer and so much to explore. We'll dive into those bigger picture questions in the next part of our deep dive, so stay tuned. All right, so we're back, and we're really diving deep into quantum computing now. Last time, we were talking about how these super delicate qubits could revolutionize everything from medicine to even like climate science.
Yeah, we talked about some of the big challenges, right? Like the error rates and scalability. But this technology has so much potential. So let's zoom in on some of the specific applications that are starting to take shape.
Okay, let's get specific. Where are we actually seeing quantum computers making a difference right now?
Well, one area that's really exciting is materials science. Imagine being able to design a material atom by atom, giving it exactly the properties you need.
Wow, so like stronger but lighter materials for cars and planes, super efficient solar panels, maybe even room temperature superconductors. Pretty mind-blowing when you think about it.
It really is. It's like having a molecular 3D printer.
Okay, so what makes quantum computers so good at this kind of design?
They can simulate the behavior of atoms and molecules with incredible accuracy. So instead of having to run all these physical experiments, which can take forever and cost a ton of money, scientists can use quantum computers to test out different combinations virtually. They can see how these materials would behave in different conditions, all inside a computer.
So it's like having a virtual lab where you can just play around with the building blocks of matter.
Yeah.
What kind of impact could this have on different industries?
Well, think about aerospace companies being able to build lighter, more fuel-efficient aircraft, or the construction industry using materials that are both stronger and more sustainable. We could even see a revolution in electronics, with new super-efficient materials powering our devices.
So from the things we use every day to life-saving technologies, it seems like quantum materials science could really touch almost every part of our lives.
Yeah.
What other areas could see this kind of quantum disruption?
Personalized medicine is another area that's getting a lot of attention. You know how your sources talk about tailoring medical treatments to each individual's unique needs?
Yeah, that's a huge shift, right? Moving away from this one-size-fits-all approach to healthcare.
Exactly. Imagine a future where your doctor can analyze your entire genetic makeup, your medical history, even real-time data from sensors to create a treatment plan that's perfectly optimized just for you.
It would be like having a team of microscopic doctors working 24/7 to keep you healthy. So what role would quantum computers play in all of this?
They could analyze massive amounts of data, way more than any classical computer could handle, and they could use that data to predict how different treatments would affect you. Identify the best options with the fewest side effects. It's like having a virtual health consultant that knows your body inside and out.
This is starting to sound pretty futuristic. I like where this is going. What about other fields? How could quantum computers change the game for things like finance or even something like traffic management?
Oh, there are so many possibilities. In finance, quantum algorithms could analyze risk and optimize investments with a level of precision that's just unimaginable today.
So no more risky bets on the stock market. Sign me up.
Haha, and imagine traffic management. Quantum computers could analyze real-time data from sensors and cameras to optimize traffic flow, potentially getting rid of those horrible rush hour traffic jams.
Yeah, that's a future I can get behind. So personalized medicine, finance, traffic, It seems like there's really no limit to what these quantum computers could do.
Yeah, and we haven't even touched on the potential impact on artificial intelligence. Your notes mention something called quantum-enhanced machine learning.
Yeah, basically using quantum computers to create even smarter and more efficient AI systems than we have today.
Right. It's hard to say for sure, but the possibilities are pretty wild. These quantum-enhanced AI systems could revolutionize fields like drug discovery materials, science, climate modeling. They could process information and solve problems in ways that are simply beyond what classical computers can do.
So basically, it's like taking everything we've talked about, personalized medicine materials, design all of it, and putting it on fast forward.
Exactly. It's a whole new era of possibility.
Hmm.
But it's important to remember we're still in the very early stages of this quantum revolution. There's still a lot of research and development that needs to happen before these applications become widespread.
It's exciting to think that we're just scratching the surface of what's possible. But with all this potential, are there any areas where we need to be cautious?
Absolutely. While there's so much to be excited about, we also need to approach this technology with a sense of responsibility. We need to think about the broader societal impact of quantum computing and make sure it benefits everyone, not just a select few.
So it's not just about the tech itself, but also about the choices we make as a society as we integrate this power into our lives.
Mm.
It feels like we're on the verge of something truly transformative.
We are. And in the final part of our deep dive, we'll explore some of these bigger picture questions and try to imagine what this quantum future might hold.
All right, listeners, you won't want to miss this. We'll be right back to wrap things up.
And we're back for the final part of our quantum adventure. So we've gone from like the basics of qubits and entanglement to actual real-world applications that are popping up everywhere.
Yeah, and now we're going to take a leap into the future. Like, what kind of world are we actually creating with this technology?
That's the million-dollar question, right? It feels like we're just starting to understand what's possible with quantum computing.
Yeah.
But where do we go from here? Your notes make a really interesting point. It's not just about the tech itself, it's also about how we choose to use it.
Right. It's like having a superpower. I mean, it can be used for good or bad.
Yeah.
What are some of the potential, like, pitfalls that we need to watch out for as this technology keeps getting better?
One thing that really stands out from your research is this idea of accessibility. Right now, quantum computing is kind of an exclusive club. It's expensive, complex, and requires a ton of expertise.
So it's like the early days of the internet when only universities and like big corporations could get online.
Exactly. And we need to make sure that quantum computing doesn't become another technology that just widens the gap between the haves and the have-nots.
Okay, so how do we avoid that? How do we make this technology accessible to everyone?
Well, it's a multifaceted problem. We need to invest in education and training programs so that people have the skills they need to succeed in a world that's powered by quantum computers.
So we don't need everyone to become a quantum physicist, but we do need people who understand how to use and apply this technology.
Yeah, exactly. And we need to ensure that access to quantum computing resources is distributed fairly so that everyone has a chance to benefit from its potential.
It's like we're building a highway to the future, right? We need to make sure that everyone has a way to get on board.
Yeah, for sure. Another area we need to be mindful of is sustainability. Building and running these quantum computers takes a lot of energy.
Yeah, that makes sense. I mean, we're talking about these super complex machines that operate at incredibly low temperatures.
Exactly. So we need to think about the environmental footprint of quantum computing and find ways to make it more sustainable.
So we want to use this technology to solve problems like climate change. But we also need to make sure that the technology itself isn't making the problem worse.
Precisely. We have to strike a balance, harnessing the power of quantum computing while protecting the environment.
It feels like we're walking a tightrope, right? We've got this amazing
Yeah.
potential, but also this huge responsibility to use it wisely.
It's definitely a challenge, but it's also a fantastic opportunity. We're at this crucial point where we can actually shape the future of quantum computing and make sure that it benefits all of us.
Okay, no pressure.
Mm-hmm.
Right. But seriously, what can we do, like as individuals, to make sure we're moving in the right direction?
Stay informed. Stay engaged in these conversations. Ask questions. Challenge assumptions. The future of quantum computing isn't set in stone. It's being created right now by the choices that we make.
That's a powerful thought. It's not just about the technology itself, it's about the values and the principles that guide its development and use.
And in the end, it's about recognizing that quantum computing has this incredible potential to make the world a better place.
Well said. It definitely feels like we've only just scratched the surface of this incredible technology. And I'm excited to see where this quantum journey takes us.
Me too. And to all of you listening out there, keep exploring, keep learning, and never stop asking questions. This quantum world is full of amazing things just waiting to be discovered.
And that's a wrap on our deep dive into quantum computing. Thanks for joining us, and until next time, stay curious.
We truly appreciate you tuning in to this podcast. Your time and support mean the world to us. If you enjoyed this episode, don't forget to subscribe to our channel so you never miss out on future content. And if you found value in what we shared, we'd love for you to leave a review or share it with a friend. It helps us grow and keep bringing you amazing episodes. Stay connected, stay curious, and we'll catch you in the next one. Until then, keep listening and keep exploring. Jardim, thank you.